these data centers take a huge amount of power. And so that's one of the stated reasons for building these data centers in space. The other thing is that they have become very contentious here on Earth, essentially where they're being placed, the resources that they're taking, et cetera. And so that's another reason why data centers could be possible in space, or why people are interested in looking at them. And then what we've seen from the SpaceX IPO or post-IPO, basically they're viewing this as one of the largest total addressable markets ever to have existed, which is essentially a space-based economy. And so I think that's also part of the element that this is really something that they're looking at as part of a huge ROI, as crazy as everything sounds right now. So, my name is Sven Bilén. I'm professor of engineering design, electrical engineering, and aerospace engineering at Penn State. Pretty much modern life. I mean, every time you do a search, every time you use an AI tool, every time you store your digital pictures, every time you make a phone call, every time, I mean, all of these things require data centers. That's just part of modern life. We tend to think of this thing called the cloud as if it's just some nebulous thing. The cloud actually has physical infrastructure that's necessary to be able to use and to do all those things that pretty much run modern life nowadays. The advantages that have been mentioned essentially include things like, the sun always shines in space, so you can get power, which is one of the big things that these space centers require. There's also the concept that you're not using usable space here on Earth, the not in my backyard, okay, it's up in orbit. And so those are some of the big things that have been mentioned. It's also been mentioned about cooling. I think that's kind of a yes and no. Certainly the background of space is very cold, 3 Kelvin, but then you have to have very, very large thermal radiators to be able to offload the amount of heat that's necessary.
To support a 1 megawatt data center, the amount of cooling panel, the size should be 2 football field. And what 1 megawatt means on Earth, with the newest NVIDIA GPU, they consider 1 rack is already 1 megawatt. 1 rack is like this size. And so now you can imagine cooling a rack like this size, you need a 2 football field radiant panel. My name is Wangda Zou. I'm a professor in architecture engineering at Penn State. There are already some data processing capability, maybe not data center scale, in the space. Because when we have satellite take image of the Earth, we can process the data on the satellite, then only send the useful information back to the Earth. And also for communication, right? When we use satellite for communication, and then the data has to be processed on the satellite, then sent to the Earth, to the right receiver. So all this is happening. Then what I think the industry proposing is to scale it up to much larger scale. When we have the data center on the space, then we can avoid the potential concern of energy, because we're not fighting with residential on energy and water, and also there's no land use requirement. For the data center developers, then they can avoid the lengthy permitting process in order to secure energy, water, and land, and also potential complaints from residents about noisy and other issues.
I think people are going to be working through the economics. I can't imagine something that size being the size of the space station, essentially being the first data center built in space. Matter of fact, there are actually companies right now that are doing sort of, I would call it edge computing in space, or have space-based data centers. I think some of the first ones will essentially be to process a lot of the data that's coming from space assets, et cetera. And so those might be smaller as we're learning before we get to large-scale data centers in space. There's just really too many challenges that need to be worked out, too many things that need to be engineered, too many neat things that need to be figured out before we're going to be building essentially on the scale that we see on Earth. But that is eventually the scale that people want to get to.